Welcome to The Explainer. Today, we're getting into something that is absolutely fascinating and honestly a little terrifying. We are talking about Google Dorking. We're going to explore how incredibly sensitive, hidden data routinely ends up right out in the open on the public internet. We'll be looking at this from both sides of the fence, uncovering the tactical search tricks used by hackers, and then flipping the script to discover the defensive countermeasures you absolutely need to protect your own digital footprint. Let's get right to it.
Okay, let's dive into this. Listen to this quote from cybersecurity researcher Johnny Long from way back in the year 2000. He originally coined the term Google Dork to mean a foolish or inept person as revealed by Google. He popularized this whole concept through the Google hacking database and talks at major hacker conventions like DEF CON. But the fundamental thing you have to understand right out of the gate is that Google Dorking does not exploit a flaw or a bug or some secret vulnerability in Google's search engine. Not at all. Instead, it exploits user error. It exploits misconfigured servers. It's all about uncovering sensitive information that was never ever intended to be public. But because of a simple, unintentional misconfiguration by a system administrator, a search engine crawler followed a link and just indexed it for the whole world to see.
So here is our game plan for this explainer. First, the threat of Google Dorking. Second, search operator architecture. Third, high-risk threat patterns. Fourth, automated reconnaissance pipelines. And finally, number 5, defensive countermeasures.
Section 1. The threat of Google Dorking.
To truly grasp the threat landscape here, we have to talk about how threat actors actually gather intelligence before they ever launch an active attack. Google Dorking is essentially the cornerstone of what we call passive reconnaissance in the ethical hacking and threat intelligence worlds. Passive reconnaissance means gathering intelligence on a target without directly interacting with their network. Think about it. If an attacker runs a standard port scan against your server, your firewalls are going to light up and log their IP address. But with Google Dorking, because the hacker is just running queries on Google's massive publicly available index, they leave what's called a zero-log footprint on your actual servers. You have absolutely no idea you're being surveilled. It is an incredibly stealthy way to map out an organization's weak spots from completely off the radar.
Section 2. Search operator architecture. Now, what's really interesting about this is the exact syntactical weapons hackers use to filter through billions of indexed web pages. We break these down into structural directives and logical operators. Structural directives are things like site:, which restricts your queries to specific domains, or filetype:, which filters results by exact extensions like PDFs. Intitle:, zeroes right in on specific HTML title tags. Then you pair these structural directives with logical operators to build some seriously complex filters. Quotation marks mandate exact string matching, the minus sign acts as a scalpel to exclude specific domains or terms, and the pipe symbol acts as a Boolean OR, letting you combine multiple query paths all at once. It literally transforms a simple, everyday search bar into a highly surgical intelligence gathering tool.
Section 3. High-risk threat patterns.
So let's look at what happens when you chain those structural and logical operators together into real-world threat vectors. Take this one, directory listing exposure. By searching for intitle: index of / combined with keywords like backup or config, an attacker forces the search engine to reveal open web directories. We're talking about raw file hierarchies on Apache or Nginx servers that admins have accidentally left completely unprotected. No index.html file to be found. So instead of seeing a normal web page, the attacker gets a direct clickable list of all the files sitting on the server. That means unindexed download links, raw source code, and incredibly sensitive log directories, just sitting there for the taking.
And honestly, it gets even more severe. Check out this query targeting exposed environment files. Filetype: env, combined with the exact string db_password. This is arguably one of the most devastating dork vectors out there today. Environment or .env files are meant to be deeply, deeply hidden within a server's backend because they contain the application's core configuration secrets. When a server is misconfigured and these files leak into a search engine's index, this query basically hands an attacker the literal keys to the kingdom. It discloses live database connections, cloud API secrets, and private encryption keys. It completely bypasses any million-dollar perimeter security the target might have set up.
There are 2 more critical patterns we need to highlight here. First, attackers will hunt for administrative portals using operators like inurl::login or inurl::admin targeted directly at a specific company's domain. This maps the surface attack footprint instantly. Finding the login screen is step 1, right?
It sets the perfect stage for brute force password attacks or credential stuffing. Second, they look for database dumps by querying filetype::SQL alongside SQL commands like insert into and the word password. This exposes full database structures, user tables, and often hashed or, no joke, completely unhashed passwords that were dumped into a backup file and accidentally left on a public-facing web directory for the crawler to stumble upon.
Section 4. Automated reconnaissance pipelines. Now, you might be wondering, are ethical hackers and threat actors just typing these queries into Google one by one? Absolutely not. They scale them. This exact 5-step passive reconnaissance workflow is a staple in professional red team operations. Step 1, they define the target scope, identifying the specific domain. Step 2, they use dorks to enumerate subdomains, hunting for forgotten development or staging servers. Step 3, sensitive file enumeration, looking for leaked PDFs or spreadsheets. Step 4, they run those configuration and backup scans we were just talking about. And step 5, they document all their findings in a reconnaissance ledger. And remember, throughout this entire methodical step-by-step process, they maintain that stealthy, zero-log footprint.
To execute that workflow at lightning speed, security professionals rely heavily on automation, usually writing simple but wildly powerful Python scripts. A few lines of code can instantly generate an entire suite of Google Dorks customized for literally any target domain. By using built-in libraries like url.parse, the script automatically handles URL query encoding, turning spaces and special characters into a format the browser actually understands. These scripts use dictionaries to map categories like database files to specific query strings. The final output, a beautifully structured list of ready-to-click Google search URLs. It takes a highly technical manual process and turns it into a fast, repeatable, and incredibly effective machine for large-scale security assessments.
Section 5. Defensive countermeasures. All right, we've seen the offensive tactics, so let's shift gears to the blue team defense and compare two completely different protocols, the robots.txt strategy versus search engine de-indexing, which is known as the no-index rule. So, robots.txt is a file at the root of your site that simply manages crawler traffic and prevents your server from getting overwhelmed. But, and this is a big but, it is a publicly visible file. And most importantly, it does not inherently hide pages from search results if they are linked somewhere else on the web. No index, on the other hand, is an absolute blocking rule. It drops the page entirely from Google search results, period, regardless of external links. So, the crucial point you have to take away here is that robots.txt is basically a traffic cop. It is absolutely not a security tool for hiding sensitive data.
Actually, I really want to emphasize this critical limitation of robots.txt because it's probably one of the most common and dangerous misunderstandings in web development today. If a sensitive web page, let's say a private employee portal, is only blocked by robots.txt and someone on a public forum randomly links to that portal, that URL can and will still appear in Google search results. It won't have a text snippet or a page description, sure, because the crawler wasn't allowed to read the page itself, but the URL path itself, totally exposed in the search results. And for an attacker hunting for a hidden admin panel or a secret API endpoint, simply discovering that the exact URL path exists is often all they need to kick off an active attack.
So to truly rip content out of the search engine index, you need bulletproof countermeasures. For standard HTML web pages, you absolutely must implement a meta tag with the name robots and content no index right up there in the HTML head section. But wait, what about all those non-HTML resource files hackers love to target? The PDFs, the .env files, the SQL database dumps? You can't put an HTML meta tag in a database dump. For those, you must use the HTTP response header xrobots tag :no index configured directly on your web server itself. Now here is a crazy paradox you have to remember. For either of these no-index rules to work, you actually have to let the crawler reach the file. If the file is blocked by your robots.txt file, the crawler can never read the no-index tag and therefore can't obey it. Mind-blowing, right? And finally, on the network defense side, deploying web application firewalls with strict rate limiting is essential to detect and block those automated dork scanning tools we looked at earlier.
Well, that brings us to the end of our explainer on Google Dorking. I want to leave you with this final and, maybe slightly uncomfortable question. Are your sensitive configurations actively indexed right now? Because if they are, someone out there might already have the dork to find them. The public web is constantly being mapped, indexed, and heavily analyzed. I highly encourage you to take these defensive lessons and apply them to your own web infrastructure today. Audit those robots.txt files, ensure your no-index tags and xrobots tag headers are properly locked in on sensitive assets, and maybe run a few site queries against your own domain just to be absolutely sure. Thanks for hanging out with us for this explainer. Keep learning and stay secure out there.